So in this video, we're going to talk about the ideal gas law, PV equals to nRT. And just for your information, the ideal gas law is based on these three fancy laws here. And they're quite basic. You don't really have to know them, okay? But basically, they investigated, right, how an ideal gas should behave under different conditions. And if realized that these things were true. And if you combine these three laws together, you would get PV equals to nRT. Right, note that T is in kelvins, N is in mole, this is of course in meter cubes, and this is of course in pascals. Now, this is a very basic law, all right? So ideal gases should behave or should obey this for all values of PV and T. If you are a real gas, in other words, a gas that is not ideal, your behavior tends to an ideal one as the temperature goes up and also as your pressure goes down. Now, what is interesting, however, in physics is that a lot of times we may be asked to use the a slightly different variation of this formula, which is PV equals to NKT. And there's a slight difference in this, just that instead of thinking of it in terms of the number of moles, we want to think of it as the number of molecules. So what we need to do is to understand the relationship between moles and number of molecules, and that is of course through Avogadro's number. Okay, so always remember that if we want to go from, maybe I shouldn't write it this way. Okay, if we want to go from number of moles to number of molecules, we always multiply by 6.02 times 10 to the 23, which is Avogadro's number. So 1 mole is the equivalent of 6.023 actually times 10 to the 23 molecules or particles. Okay, and of course that means also the relationship between R and K to make this equation mathematically correct means you just have to divide by 6.02 times 10 to the 23, and you can check this, right? R is about 8.31 and K is about 1.38 times 10 to the minus 23. And so there you have it, the ideal gas law in two separate or two different ways to express it.